For our project, we're doing the Galilean thermometer, and this edpuzzle is about density and its importance to our project.
Okay, so first we have to start by defining density. So density, simply put, is how compact a substance or object is. And we can also say this as the measure of mass per volume within an object. So you might be wondering, what exactly does the degree of compactness mean? So compactness of a substance is pretty much just how close together the molecules of a substance are. So over here we have some drawings of more and less dense substances. So in the first one, we can see that the molecules are further apart, meaning that it's less dense. And in the second one, the molecules are much closer together and more packed together, so the object is more dense. So now that we have a basic understanding of density, we can now go into how to find it. So what is the formula for density?
If you said density equals mass over volume, you'd be right. So what exactly is that symbol that looks like a P with no stem at the top and a curve at the end? It's actually the Greek letter rho, which is just the symbol for density used in physics. So now that we've established the basic formula for density, let's break it down.
Volume is just the amount of space that a substance or object occupies, or that is enclosed within a container. It is a three-dimensional quantity and can be used to measure any substance, solid, liquid, or gas. So now moving on to mass. What exactly is mass? So mass, simply put, is just the measure of the amount of matter in an object. Mass determines gravitational strength and is also key to buoyancy. So why exactly does all of this stuff about density matter to the Galilean thermometer? The Galilean thermometer contains 3 or more floating bulbs that each have different amounts of different colored liquid inside of them. When you look at the thermometer, the bulb floating closest to the middle will determine the temperature. So the bulbs in the Galilean thermometer float up and down based on the temperature of the outside liquid, which depends on the temperature of the outside air.
But why exactly do the bulbs float up and down, and how does this relate to density? The bulbs float up and down because of changes in density of the surrounding liquid. Because of thermal expansion, the density of the surrounding liquid depends on the temperature of the surrounding air. If the temperature is lower, the liquid will have less volume and therefore be more dense. If the temperature is higher, the liquid will have more volume and therefore be less dense. Also, if the density of the bulb is greater than the density of the fluid, the bulb will sink. If the density of the bulb is less than the density of the fluid, the bulb will rise. If the densities are equal, the bulb will float in the middle. The bulb floating closest to the middle determines the temperature. And here is a drawing of a bulb. So next we have an illustration of what will happen when the thermometer is exposed to a heat source. So we can see that this part has less volume, therefore it is more dense. When exposed to a heat source, the temperature of the liquid surrounding the bulbs in the thermometer will increase, which also increases the volume.
We can see in this picture that there is a greater volume for the liquid, which means that the liquid will be less dense. This causes the position of the bulbs to change and is how we read temperature.